Welcome to today's lesson. My name is Kaonga Samuel. So really this is for you, those of you who are in grade 11, grade 10, grade 12, especially those who are in grade 12, because you'll be writing your exams very soon. So this is going to save us a revision. So what we're going to do today is just to look at bearings. Okay, so let's look at bearings. Wow, that's too big. Let me just try to reduce that a bit. Okay, that's too big, it's too thick. Maybe we could just bring it closer to 3. Okay, so let's look at bearings. Yeah, this is much better. Bearings. Okay, so straight into a definition. What is a bearing? Okay, so a bearing is an angle measured clockwise from the north. That's a bearing. An angle that is measured clockwise from the north. That is what a bearing is. Okay, an angle measured clockwise from the north. So if I have, okay, if I have, let's say I have this one here. So if this is my north, and then this is A, and then this is B. So we say from the north, clockwise from the north to the arm there. This, let's call it theta. Okay, so you discover that theta here, theta is equal to the bearing of B from A. Okay, theta is the bearing of B from A. That is theta, the bearing of B from A. Now, there are certain things that are going to be helpful for us to understand bearings fully. You need to understand, let's look at the concepts that you need to really understand. Concepts or properties. Okay, so Z angles, alternate angles, Z-shaped angles, which we call alternate angles. These are always equal. Okay, Z-shaped or alternate angles, these are always equal. So if you've got an angle like this, if these are two lines, parallel lines, and then there is a transversal line there, so you discover that, let's just clear this a bit. Okay, these are parallel lines. So you can see that here we are forming some sort of a Z. Okay, there is some sort of a Z that is formed. Okay, here, so that one, okay, and then there, and then there. I hope you can see that there is a Z shape that is formed. So the angle here and the angle there, these are what we call alternate angles. Alternate angles, these are Z-shaped angles. Z-shaped are always equal. So this is an important characteristics for us to understand how to calculate the bearings. Okay, so try to take note of the Z. Sometimes you can be given something like this, okay, a shape like this, okay, a shape like that, okay. So still here there are alternate angles there, you can see. Let's choose something that is going to help us highlight what we want to highlight nicely there. Okay, so you can see that there is also a Z there. Okay, there is also a Z there. So you discover that this, okay, and that, and that. I hope you can see that Z. Okay, so that Z there, so it implies that the angle here, okay, let's just clear this. So if I have this as my lines, so the angle there is equal to the angle there. Okay, these are alternate angles. Very, very important. Another concept that is going to be of help is the concept of triangles. So you need to understand the triangles, the characteristics, the types of triangles and their characteristics. Okay, an isosceles triangle, an equilateral triangle, you need to understand the characteristics of those triangles. Okay, so straight away let's just jump into exam questions and see how we can solve bearings. Okay, okay, so let's just create space for exam questions there. Let's create some space for exam questions that are right on my side there. Okay, let's just create and leave room for these guys. Okay, so let's have this question first. Question 1. The first question says, in the diagram below, A, B, and C are 3 points on level ground. The bearing of B from A is 062 degrees and angle ABC is 128 degrees. C is due east of A. C is due east of A. So when we say due east, it simply means the angle at the origin where the angle is coming from, there is a 90 degrees there. So C due east of A, it means that there is a 90 degrees at A going to C. There is 90 degrees there. That's the meaning of due east or due west. There is a 90 degrees there. All right. So the question is there before us. Let's just jump into the solution slide. Okay, let me just try to reduce this a bit. Okay, so for this one here, what we're going to do is, okay, we have to create the notes in advance. Okay, let's try to create the notes in advance. Okay, so you discover that here I'll have my north at B. Let me have my north there at B. I'll create a north. This north will help me. Okay, so this north there will help me. So we can say My north is there. Okay. Let's also create a north here at C. Okay. Now I have the north here and I have a north there. Okay. I have a north there, I have a north, north, north. So you discover that these are parallel lines. The three norths there, they are parallel lines. You understand now the concept of alternate angles where it comes in handy? So let's look at the first one. The first one says, find the bearing of C from B. C from B means from the north of B to the arm of C, or to the line that leads to C. From the north of B to the line that leads to C, that is C from B. Okay, meaning we want to find this bearing here. This is C from B. Okay, C from B. From the north of B to the arm of C. Now let's check it out. You will discover that this angle here, this side, this angle here, let's just change the pen there so we can see nicely. You will discover that this angle here, okay, here is alternate to that angle there. And we know this angle is 62 degrees, okay, 062 degrees. So if this is 62, then I know that this is 62 degrees there, okay, meaning from 128, my remainder now is going to give me, okay, minus 62 degrees. I'm going to remain with this here as 66 degrees, okay. 66 degrees is my angle here. Now I know that angles on a straight line, they add up to 180 degrees. You will discover that here, this is my straight line in blue there, in blue. This is my straight line there. This is my straight line, okay. So angles on this straight line, they add up to 180 degrees. So for me to get now the bearing of C from B, I'll simply subtract, therefore, C from B is simply going to give me 180 degrees minus 66 degrees, which is going to give me 180 minus 66 degrees, which is going to give me 114 degrees there. Okay, that is my bearing of C from B. I hope you are following and following right. All right, what about A from B? Let's just clear this. Let's just clear that. Okay, so we can have A from B. Okay, now for A from B, for this bearing there, just put this back. Okay, A from B, what that simply means is that the north there, from the north, I mean A from C, sorry for that, A from C, okay, A from C is this angle here, from the north of C to the arm of A, from the north line of C here, all the way to the arm of A. This is the bearing that we want. A from C, that is the bearing that we are looking at. Okay, A from C. So meaning from the north of C to the arm that leads to A. So what would be the solution there? You discover that here we're going to say A from C, okay, A from C is going to give us 180. So A from C is going to be 180 plus 180 degrees plus 90 degrees, which is going to give us 270 degrees. That is the bearing of A from C. That is the bearing of A from C, which is going to give us 270 degrees there. Okay, so this here is an alternate angle to this one. So this angle here, this angle alternates with that angle there. Okay, you can see this is 90 degrees, this is also 90 degrees there. All right, so for question 1 we are done. That's how basically you should work when you are dealing with bearings. So question 1 we are done. Let's consider question 2. So here from this one, we can say that the bearing of C from B, the solution to this one is going to give me 114 degrees. The solution to this one is going to give me 270 degrees. Okay, let's move on to question number 14. This question, I don't know which year is this, but it's question number 14. So this one says, in the diagram below, F is due east. Please take note. When we say due east, it simply means there's a 90 degrees where the bearing is coming from. So due east of E, angle GC is 60 degrees and angle EFG is 40 degrees. All right, as you can see in the diagram there. Calculate the bearing of F from G, meaning from the north of G to the arm of F. F from G simply means from the north of G to the arm of F. So let's just create the norths in advance. Okay, so let's get our beautiful ruler there and create these norths in advance. Okay, so I can have my north line there and just do it from this side. Okay, I have my north lines there and my north line here. Okay, my north line there. I can also extend this one a bit so that I see clearly what is I'm supposed to do. Okay, having done that, now we can see that this is my north, that is my north, and that is my north there. So I've got 3 norths there. Now the bearing of F from G means from the north of G to the arm of F. From the north of G to the arm of F, what are we looking at? So from the north of G, G is right in the middle. From the north of G, G is here, to the arm of F. This is the bearing that we want there. Okay, this is what we are looking for. From the north of G to the arm of F, we are looking at this bearing. What is going to be this bearing? Now you will discover that we have been told that F is due east of E. Okay, meaning the angle here, that simply means the angle here. Okay, the angle here, the angle at E here, this is 90 degrees. This is 90 degrees. Okay, when we say due east, it simply means there's a 90 degrees somewhere. So that is our 90 degrees. Now 90 degrees plus 60 degrees, it is going to give you what? It is going to give you, we're going to subtract for us to get this angle here, which alternates with that angle. okay, we are going to have 180, okay, less 90 and 60 there, which is going to give us 30 degrees. So this angle here is 30 degrees, okay, 30 degrees. So because this angle alternates with this angle there, so this angle is also 30 degrees, okay. This angle is 30 degrees. Now angles inside a triangle, they add up to 180 degrees. Angles inside a triangle, they add up to 180 degrees. So you now discover that, okay, if this is my triangle, I know that the angle here, okay, the angle here, the total angle from there, this angle here, in total, this is 180 less 100. 60 plus 40 inside the triangle, you get 100. 100 less 180 less 100. Now we are going to have from there to there, we are going to have 80 degrees. Now we've discovered that this is 30. So to get the remaining bearing here, which we are looking for, we're going to say 80 less 30. We're going to have 50 degrees there. Okay, this is going to be our 50 degrees. So this is the bearing of F from G. F from G. So therefore, F from G is simply going to give us 80 degrees minus 30 degrees, which is going to give us 50 degrees. All right, we are done. That is our F from G. Okay, the next bearing that we have been told is E from G. E from G. E from G. Okay, E from G, meaning from the north of G to the arm of E. Okay, E from G. Which bearing are we looking at? Let me just clear this a bit. Okay, let's preserve our north. Okay, E from G is the bearing, okay, from the north of G to the arm of E. We are looking at this bearing there. Okay, all the way to the arm of E, which is here. This is E from G. That is the bearing that we are looking for. Okay, now when you look at this, okay, we are coming from the north. Okay, let's just have this north back. Okay, so we are saying E from G. So what we're going to do here is to use the concept of angles on a straight line. So from there, from here to here, we have 180 degrees here. This is 180 degrees. Now, what is this angle here? Okay, this angle there. So you discover that this angle here alternates, okay? This angle here, okay? It is an alternate angle of this. This angle alternates with that angle there. Okay, that angle there. These are alternate angles. Now, I hope you can see that this angle on top there is 90 plus 60 degrees. Okay, 90 plus 60 degrees. So, which is going to give us 150. So, this here is, in actual sense, this, let me just reduce this a bit. This is 150 degrees. Okay, 150 degrees. That is 90 plus 60 degrees. Meaning that this also here is 150 degrees. Now, we want the bearing from the north of G to the arm of E, which is here. So, therefore, the bearing, our solution is going to be is, what we're going to have now is E from G, E from G is equal to, okay, is equal to 180 degrees plus 150 degrees, which is going to be equal to, okay, 150 degrees, which is going to give us 330 degrees there. Okay, we are done for this one. I hope we have understood. All right, so that is E from G. The next question. The next question says, the diagram below shows Mr. Moenda's trip. He travels on a bearing of 141 from A to B. He then decides to continue with this trip from B on a bearing of 225 to C. The angle BCA is 35 degrees. Okay, find the bearing of A from B and the bearing of A from C. So A from B means from the north of B to the arm of A. A from C means from the north of C to the arm of A. Right, very simple indeed. Now we have been told, so here what we can do is let's just create a north in advance as well, so that it can help us to really do what is correct there, so we can have a north there in advance. This is just there to help us. Okay, I can have my north there created in advance. Okay, I can extend this north there. I can have this extended there. Okay, and I can have that extended there. There's no problem. Okay, there's no problem, so that I see things the way they ought to be seen. Okay, so let's now do the work. So this is my north. So remember, these are parallel lines. So A from B simply means from the north of B to the arm of A. Okay, so what are we going to do there to calculate A from B? From the north of B, from the north of B here to the arm of A, what are we looking at? We are looking at this bearing there, all the way up to here. Okay, that is A from B. Okay, we are starting from the north. Remember, bearings are measured from the north. So from the north of B all the way up to the arm of A. This is the arm that leads to A. Okay, the line that leads to A. So that is the bearing that we are looking for. So this is really something that is not challenging at all. You would discover that, okay, this is 225, all right? The angle here, let's see, the angle here is going to give us the same as the angle there. Okay, the angle here. So this angle is 180 less, okay, 180 less 141. We're going to have a 39 here, a 39 there. Okay, if that is 39, we know by alternate angles that this is also 39. Okay, this is 39. All right, that is 39 as well. If this is 39, what will be the angle of B? So I'll simply say the remainder now here, what I'm going to do is to say, okay, this is 255, okay, less 39. I'm going to know what is there, so we're going to say 360 less 255 less 39. So I have 66 here, meaning from there to there is 66. Okay, 66. So meaning what I'm going to do is to say, okay, angle A from B, angle A from B is going to give me, so I know that here I'm going to have 66. So I'm going to say A from B is starting from there to there. I've determined that from there to there it is 66. So what I'm going to do is to just get a 255 there, add a 66. Okay, what I'm going to have is 255 plus 66. What I'm going to get is a 321 degrees. Okay, that is my required bearing of A from B. Okay, 255 plus 66, which is going to give me a 321 there. All right, the other one is A from C, from the north of C to the arm of A, meaning A from C, we are looking at this bearing there. A from C, it is just this bearing there. That is what we are looking for. That is our A from C. Okay, A from C, that is the bearing. Okay, so for me to find this bearing here, what we are simply going to do is to say, okay, I know by alternate angles that this angle here, let's check it out. If I take this path there, please bear with me. If I take this path here, please let's follow it together. If I take this path here, I want you to see it. If I take this path there, okay, this is too thick. Let's just try to clear it. This is too thick. Let's reduce the ink a bit there. I've just given it too much ink. Okay, if I take this root here, this root there, okay, you can see that this angle here, this angle there, this angle here is equal to 66 plus 39 degrees. Okay, which is going to give us what? 66 plus 39 is giving us 105. So meaning this is 105. Okay, now 105, to find this angle here, we are simply going to say 180. So A from C, A from C is going to give us 180 minus 105 plus 35 there. Angles on a straight line. So this is going to result into, so 180 minus 105 minus 35, which is going to give us 40. So this is going to give us 40 there. So 40 degrees. Okay, 40 degrees. So really, this is what you do when we are dealing with bearings. I hope this is helpful, especially to those of you who had a bit of challenges. Really, what is important is for us to see the properties behind these bearings. Simple and straightforward. So let's just have this pen there. Okay, so allow me to clear this. Allow me to clear this. so we can have something that is clean there. Okay, so the bearing there is going to give us 321 degrees there and 040 degrees there. Okay, that's it. Let's look at the last question. Okay, let's look at the last question and then we can call it a day.